Part B. On what open intervals contained in -3 is less than x is less than 4 is the graph of f, both concave down and decreasing? Give a reason for your answer. All right, so f needs to be both concave down and decreasing. So f concave down, that's going to be true if and only if the second derivative of f is less than 0, which is true if and only if f prime is decreasing. F prime is decreasing. So that's how we can tell when f is concave down. And I want to see, what do I need to observe on f prime, because that's the graph they give us. All right, now for f to be decreasing, f is going to be decreasing if and only if, well, you're decreasing when you have a negative slope, if your rate of change is negative. So that's true if and only if f prime of x is less than 0. So both true when f prime of x is less than 0 and decreasing. And, let me write, and f prime is decreasing. And f prime decreasing. So let's see if we can identify that. Let's go back to our graph and see when is f prime of x less than 0 and decreasing. So if we look at less than 0, let me highlight this so less than 0, I'm highlighting it in magenta right over here. This is all the places where we are less than 0 in magenta. And now of that, where are we decreasing? Well, we are decreasing over this interval right over here. So that would be -2 is less than x, which is less than -1. So that's, we're decreasing. Of the places where we are negative, I'm taking the subset of where we are negative to think about, well, where are we decreasing? We're decreasing right there. And we're also decreasing right over there. So that is 1 is less than x, which is less than 3. Now we are decreasing before x equals -2 over here, but we're not less than 0 there. So I'm not going to include that. And so we have our intervals. So our open intervals. So we have both true when these two things are true. And so this happens when -2 is less than x is less than -1, or 1 is less than x is less than 3. So those are our two open intervals, this one and that one.